Um, it's a pretty bold statement, an error that's found in most designs worldwide. In fact, it's a little bit stronger than that. I haven't seen one that hasn't had it, uh, particularly when they're having problems. So just want to share this with you and also share why I think it's there. And then I've listed some contact information. And most of my career, and I've had about 25 years with a global job, most designs are working like they were designed. And when I go to solve the problems, the problem is the design. It's not the operators. Okay, so just my standard disclaimer, while all my stories are true and related in a technically correct manner, I've often forgotten where they occurred because I'm old. Thus, references to specific companies and locations are meaningless and should be regarded as pure fiction. So the agenda, just a brief introduction. I want to get to a safety moment. And what I want to share with you and hope you get from these are things that you may not know that you find of use, and then things that you can apply immediately to your jobs and make your company more money. So we'll look at the design error, what it is. I'll show you a wet chemistry demonstration. So, why believe what I say? We'll show you with actual fluids. And then we'll take a trip to Brazil. That's me on the far left there. And that's Dr. Walsh. We were both on an FPSO we'll take you to that was having some problems. We'll show you how we solve the problem, give you a checklist that you can use at your own facility, and then we'll open it up for questions and answers. So I've got about 40 years experience. I'm a registered engineer, got a BS in chemical engineering and an MBA, and a lot of experience globally. Okay, so I want to talk about ignition sources and classified areas. Clearly, there's a problem here with this guy grinding next to the explosion-proof enclosures and how they work. And these are just some examples. I'm sure you've seen them in the field or offshore. What I ask you to do is just text. The way they work is by not allowing explosive mixtures to come in contact with arcing and sparking switches, or they actually create the explosion within the box. Expect, and that's what I want to show you. They create an explosion inside the box. And so I'm going to show you a movie, and the story, it's pretty hard to see what's going on. But that explosion-proof box, you can see, just has a plate on front of it. There's an ignition source inside, and then there's a clear box around all this stuff that's surrounded by a combustible gas at the flammability limit. So what happens, and the thing about is the gap between the faces on these explosion-proof fixtures. What happens, and the reason the flanges are so wide, is it's used to quench the explosion, or the flame front. It works similar to a flame arrestor. So the velocity and the speed at which the hot gases after the explosion in the box are cooled. And what you're trying to do is prevent the flame front from exiting the box into the surrounding cloud that has a larger mass of hydrocarbon, and thus preventing the explosion. So if you don't maintain these faces, if they get corroded, or you paint the faces or paint the boxes, they won't work. So once you understand how the boxes work, you can work around them more safely with other people who don't understand how these devices work.
The small explosion and prevent it from propagating out of the enclosure. A flame-proof enclosure is not 100% airtight. Gases can escape after an internal explosion, but only by traveling along very narrow gaps, such as these wide, close-fitting metal surfaces. Gases are cooled and become unable to ignite a flammable mixture. There is no minimum gap, but there is a maximum gap for any particular piece of equipment that must never be exceeded. The importance of these gap sizes. The smaller box here is a model of a flame-proof enclosure. The larger box represents the surrounding environment. The flame-proof enclosure has a small gap along one of its joints, the size of 0.8 of a millimeter as labeled. For this setup, such a gap is within acceptable limits and is still safe. There is a flammable mixture of gas and air in both the flame-proof enclosure and the surrounding box. Now, a spark. Since the flame-proof enclosure is effective in containing the explosion, the flammable mixture in the large box does not ignite. But with the gap enlarged to 2 millimeters instead of 0.8, a spark instigates an explosion that does propagate out of the flame-proof enclosure into the surrounding box. In practice, this surrounding could be a section of a plant. It can withstand.
You might pass that on at a tailgate meeting with your operations people too. A lot of people don't know how the devices work. The error that I'm going to tell you about now that exists in oil dehydration and water treating plants, why does it exist? Well, we've got separator sizing based on Stokes' law and residence time and momentum, and fluid properties. HYSIS, the designers use, they don't have emulsions or oil treating chemicals. They just have oil and water, and they're interested in the actual with emulsions and what can happen. And then when all else fails, we contact the chemical people, and they put in water emulsifiers, surface active agents, water treating chemicals, but all their stuff's proprietary. And it's kind of black magic, and it's secret. It's not in process simulators. It's not understood by the contractors. They'll put in the capability to add the additives, but they really don't concern themselves with what happens. And the other thing is it's not well understood by the owner engineers either, or the operators. When you're in really big trouble, most people just pump more chemicals or contact more chemical people to help them out when the separators aren't separating. So this is the answer. So I'll start off with what you never do. You never mix fluids that have contacted oil demulsifiers and also water treating chemicals. Okay, so you never ever want to do that. And there are very few things in engineering that you say never to, right? Just like an error that's found pretty much everywhere and always. And then you never recycle slop oil to the front end of your process stream. Your main process stream is your money stream, and you don't want to do that, and I'll show you some reasons why.